Bonjour à tous, mon nom est Raphaël Chaire et on va entamer le premier bloc qui se nomme Stratégie d'aménagement forestier. Le prochain présentateur sera Sanghyun. And continuous cover forestry maintains soil fungal communities in Norway spruce dominated boreal forests. Thank you.
Hello, I'm a new PhD student, Sanghyun Kim, under the supervision of Professor Miguel, Eve, and Dr. Patricia. Today, I'm going to talk about my previous research in Sweden. In Sweden, I found that continuous cover forestry maintains soil fungal communities in boreal forest ecosystems. According to the FAO 2020 report, the world's forest area declined by nearly 5 million hectares a year since 2010. That is more than the size of Denmark. Forest area has been decreasing while demands for timber is increasing. So someday we may face the wood crisis if we don't concern deforestation. Boreal forests are in a crisis because of the homogenization and simplification of forest structure and climate change. The boreal biome has been intensively managed and producing 1/3 of timber in global trade. And they are undergoing climate change, such as drought and heating. So we should find a way to manage boreal forests sustainably. Okay. Currently, clear felling is still the dominant harvesting practice used in boreal forests. This harvesting system alters biodiversity, ecosystem function, and services. Continuous cover forestry also has been proposed as a potential alternative to clear felling. In continuous cover, 30 to 40% of the standing forest volume is harvested every 15 to 20 years. So it maintains a continuous tree cover. This harvesting system mimics small-scale disturbance regimes typical of Norway's spruce-dominated forests. So we can follow a trend of developing forest management practices that mimics natural disturbance and it conserves forest communities while improving productivity. But in this context, we still don't understand the impact of harvesting on soil fungi. Yeah, fungi are important mediators of biogeochemical processes. In boreal forests, mycorrhizal fungi are more important due to its poor nutrient condition and core damage. So we need to assess the impact of forest management on fungal communities. Future forests may be more vulnerable from anthropogenic disturbances. Yeah. To assess the impact of clear-cut and continuous cover on soil chemistry and fungal communities, we sample homogeneous forest stands subject to either clear-cut, continuous cover, or no treatment. Study sites are located in the mid-boreal zone of Sweden. To broaden our inference space, we include 4 different sites to incorporate site heterogeneity resulting from variable historical differences, but also meteorological factors. These are the photos of each study site. It looks pretty similar among sites. Left side is clear fell treatment and right side is continuous cover treatment. To assess the impact of forest management on soil chemistry and fungi, we sampled 10 randomized scalar plots per treatment at each site. So 120 soil samples in total. Sampling time was during September 2018. And to analyze soil chemical properties, measured soil pH, organic matter, carbon, nitrogen, and carbon to nitrogen ratio based on standard protocols. To analyze soil fungal communities, we applied empirical metagenomics. So let me briefly show you how I conduct this analysis. First, we collect the soil, and store it in the icebox and -80 degree freezer. And then samples were freeze-dried and finely ground before DNA extraction. Following that, we sent this sample to SLU, Uppsala. And ITS region is a DNA barcode for soil fungi. In this ITS region, we collaborate with a mycologist, Professor Bjorn. So we chose these new primers developed by him. These primers provide higher accuracy for longer amplicons. And we used the latest sequencing platform called PacBioSequel. It costs more than MISIC by Illumina, but well detects fungal amplicon. And we used the scatter pipeline to analyze and quality check for soil fungal sequences developed by SLU. From this stage, I traveled to Uppsala to conduct this work with Professor Lindar. And additionally, fruiting body were assessed to determine whether the broader findings from the sequencing data were also apparent. Fruiting body is an important and easily observable component of the holistic soil fungal community. To assess how forest management influences fungal fruit body abundance and composition, we revisit the randomized plots in the study sites during October and harvested all mushrooms within 1.6 square wooden frame. The sample mushrooms were identified according to Swedish taxonomic literatures. The number of mushrooms are quite many in the time. So I invite people every week to help identify mushrooms. And for the data analysis, we use the statistics, univariate analysis with mixed effect model, two-case pairwise, and multivariate analysis with PERMANOVA and SIMPER analysis. Okay, now let me show you the result of amplicon metagenomics. Approximately, we identified 2,157 species hypothesis, and the most 5 common species occupied 9% in total abundance. For the fruiting body, we collect in total 1,825 mushrooms and identify 43 mycorrhizal fungi out of 120 species in total. We found that soil chemical properties, fruit body biomass, and fungal diversity were strongly influenced by forest management practices. We detected significant effects of forest management on soil pH, carbon to nitrogen ratio, fruiting body abundance, dry weight, fungal diversity indices, and species richness. The significant influence of forest management on soil pH, carbon to nitrogen ratio, diversity index of fruiting body, and species richness of soil fungi was driven by two pairwise differences. Here you can see clearly fruiting body and soil fungal communities have distinct clusters in the canonical analysis of principal coordinates. Fruiting body, dry weight, and abundance communities in continuous cover and unmanaged forest were more similar each other, but clear fell forestry tend to form a distinct group. But regarding soil fungal communities, all three treatments appear to be distinct from each other. Here in the simple analysis of soil fungi, we can see 25 species accounts 15% of the average dissimilarities, and three soil fungal species were important drivers of differences in community composition between continuous cover and clear fill. Floating body abundance data was performed in the same way. And we detected significant relationship between soil variables and fungal diversity indices with these linear regression models. The soil pH was significantly and positively correlated with the soil fungal diversity index and species richness. Soil carbon to nitrogen ratio was close to significant and negative correlation with soil fungal species richness. In the distance-based linear models, we found that soil fungal community composition was influenced by all soil chemical variable, especially pH and carbon to nitrogen ratio had the highest explanatory value. Likewise, the result of floating bodies also shows soil pH and carbon to nitrogen ratio were the variables with the highest explanatory value. Okay. Our findings provide strong support for the use of continuous cover, maintains soil communities and chemical properties similar to that of unmanaged forest in boreal forest ecosystems. Regarding both soil fungi and chemical properties, continuous cover was consistently similar to unmanaged stands. But the why clear fell is so different because the removal of the majority of the stems in clear fell area has large effects on abiotic conditions such as moisture and sun influx. Furthermore, clear felling can also cause substantial disturbances to soil ecosystem and affect soil erosion, nutrient cycling, and water quality in the forest ecosystems. Lastly, a complete harvest also cuts the photosynthetic input of trees to fungi and leads to the death of mycelia, so initial release of carbon to soils. But at the end, we had unexpected findings that forest management practice had opposite effect on fruiting body compared with soil fungal diversity. Regarding fruiting body biodiversity, it could be variable depending on harvesting season. We harvest only one time on September. For soil fungal diversity, we assume that the reason for us finding a higher diversity of soil fungi richness in clear cut than in unmanaged and continuous cover, it may result from the quite recent logging disturbance because harvesting was conducted just 4 years ago from sampling time. Clear cut can increase suitable habitat for the colonization of generalist fungi, so it retains some of the species from more mature forests. I think the 3 fungal species in soil fungi and fruiting body can be the indicator species that are vulnerable or preferential to timber harvesting. I extract 3 species per data set and interpret the relationship between environment and fungal ecology. For instance, this earthfan fungus is known to be abundant in regenerate stands. We show that fruiting body and soil fungal community composition are sensitive to change in soil chemical properties. This is likely because fungi typically respond differentially to environmental factors according to their functional group and special traits. So here are the take-home message for today. Mimicking natural disturbance during harvest may reduce impact on forest ecosystems And we saw that clear felling had pronounced effect on biological and chemical properties of soils. And the continuous cover, namely partial harvest of 30%, maintained similar fungal communities to unmanaged forest. And variation in soil fungal communities correlate to soil chemical properties. So in conclusion, continuous cover forestry is a promising option for maintaining soil ecosystems. You can find out more here in this paper. Yeah, thank you.